Before we begin this month's program, here's a quick look at what you'll find in the tech news. The winners of the Ultimate Race Weekend contest took a trip to Michigan International Speedway in August to participate in a NASCAR race, and the tech news brings you the details. Some highlights of that weekend are also featured in a short video segment that follows this month's program. Be sure to take a look. Training Tips focuses on courses related to the subject of this month's program, the Cummins high-pressure common rail diesel engine. There's also a list of the software available for updating the MDS2 and DRB3. Now stay tuned for an in-depth look at the new diesel power plant for Ram 2500 and 3500 series pickups.
As you've seen from past Mastertech programs, the introduction of the 2003 2500 and 3500 series Ram pickups brought along with it changes to the powertrain lineup for these trucks, including a new Cummins diesel engine. And new really is the right word here, since both the engine and the fuel system have been redesigned. Welcome to this month's program. Cummins high-pressure common rail diesel engine, also referred to with the abbreviation HPCR. To familiarize you with the service features of the new Cummins engine, we'll lead off with an overview that looks at some general items, such as the main engine features and engine identification. Then we'll cover the engine and engine-related systems in detail, including changes to the duties of the engine control module and notable inputs and outputs. We'll wind things up by looking at diagnosis, focusing on the information, tools, and tests you need to be familiar with. The Cummins high-pressure common rail diesel engine has several features which allow you to distinguish it from previous Cummins engines, particularly when it comes to the fuel system. Instead of a pump which sequences high-pressure fuel to injectors at the proper time, the new fuel pump supplies a common rail with high-pressure fuel, which is in turn fed to the individual injectors. The injectors deliver fuel to the cylinders as the result of a signal from the engine control module, not as the result of a pulse of high pressure from the pump. The fuel supply side of the system is also new, with a new fuel filter and water separator and a new transfer pump. The engine itself uses an all-new cylinder head and block, and attached to the lower end is a block stiffener. The front of the engine also reveals some major differences, such as a power steering pump that is now belt and not gear driven. In fact, most of the parts on the new Cummins diesel engine are different from the previous version. There are also changes in engine calibration and specifications. In fact, there are 5 versions of the HPCR engine, and they're listed in this month's reference book. As you can see, the classification involves the emission certification and which transmission the truck uses. The configurations include a high output or HO version, which produces 305 horsepower and 555 pound-feet of torque. For now, it's available only with the NV5600 manual transmission. This engine, and all other engines coupled to manual transmissions, are compatible with a Mopar accessory exhaust brake. Speaking of transmissions, besides the NV5600 used with the HO engine, there's also an automatic, the 47RE, and a manual transmission, the NV4500, available for standard output engines. Both of these combinations have CARB and federal versions to meet the different emission specifications. The HO engine has only a federal version. Later in the model year, a 48RE transmission replaces the 47RE. Unlike the 47RE, the 48RE will be available in HO applications, and it will be exhaust brake compatible. Just like previous Cummins engines, the HPCR engine has an engine data plate. On this engine, it's affixed to the accelerator pedal position sensor bracket or to the breather cover, depending on the build date. Among other items, the plate contains the engine serial number. The engine serial number is also stamped on top of the block above the oil cooler boss. In the area of routine maintenance, you'll find that the oil and filter change interval has been revised. A table in this month's reference book summarizes the changes. Notice that in addition to interval differences between normal and severe service, there are also differences between federal and CARB certified engines. The final item that we need to discuss up front is one that you'll be hearing about a few more times in this program: the need to take care when dealing with a fuel injection system. On the HPCR engine, fuel system components from the high-pressure pump to the fuel injectors deliver diesel fuel under extreme pressure. This high-pressure fuel can cause serious injuries or death. So you should never attempt to loosen or remove these components when the engine is running. And no, you don't have to crack open lines to bleed the system after repairs, or if the truck has run out of fuel. The system is self-bleeding. The service information and diagnostic procedures detail the safety precautions and warnings that apply to the HPCR engine. Be sure to read them before performing diagnosis or service. Next, we're going to explore the features of the new Cummins HPCR in detail, beginning with the accessory drive and then working our way around the engine. At the front of the Cummins HPCR engine, you're going to notice a number of features which are different from those on previous Cummins engines. As you learned from last month's Mastertech, there is a heater-only system available. And to accommodate this change, the accessory drive belt tensioner now has two positions, AC and non-AC. In the area of accessory drive components, you'll also notice that the power steering pump is now driven by the accessory drive belt instead of by a gear. The vacuum pump, which was previously combined with the power steering pump, is no longer used. However, it is available as a Mopar accessory for trucks using an exhaust brake. The HPCR engine uses a new crank damper with a tone wheel behind it. The crank position sensor is mounted at the front of the block near the bottom of the timing gear case. One of the gears on the front of the engine drives the high-pressure fuel pump, and you can still remove it from the pump through the access cover with the special tools used previously. Once you remove the nut, you'll notice that the gear is no longer keyed to the pump shaft because the pump is not timed to the gear train. When you remove the front cover, you'll notice straight cut gears which are thinner than those used previously. In addition to the fuel pump gear, the crankshaft gear drives camshaft and oil pump gears. Speaking of the camshaft, the engine does not need to be removed from the truck to remove it. However, you will need to raise and support the engine. We'll discuss the tools used to do this a little later on. Right now, let's move on to the side of the engine to take a look at the new fuel system components. To bring fuel from the tank, there's a new transfer pump, which is attached to the housing for the fuel filter and water separator. The transfer pump, also known as lift pump, can be serviced separately. Note that the drain valve and water in-fuel sensor have moved from their locations on the previous engine. Later on, we'll discuss some of the tests used to check whether the fuel supply part of the system is supplying the high-pressure pump with fuel and is free of leaks. Earlier, we told you a little bit about the high-pressure fuel pump, namely that it is now used to supply the common rail and fuel injectors with high-pressure fuel, and that it does not sequence the fuel injection. The new pump, which goes by the designation CP3, actually uses two stages to pressurize the fuel. The first stage raises pressure to about 200 psi, and the second raises it to between 5,800 and 23,600 psi. The engine control module regulates the amount of pressure by sending a pulse width modulated signal to an electronic fuel control actuator in the pump. This actuator admits more or less fuel to the pumping chamber based on the signal. To monitor how much pressure is produced, the ECM relies on a fuel pressure sensor. The high-pressure pump is serviceable only as an assembly, but as with any component, you need to perform a thorough diagnosis before deciding to install a replacement. We'll get into diagnosis later in the program. The pressure sensor we referred to is located on the common rail. By now, it's probably pretty obvious that the fuel line setup is quite a bit different than on the previous Cummins engine. So at this point, let's follow the lines from start to finish, beginning with those responsible for supplying the high-pressure pump with fuel. The fuel supply line from the tank is connected to the transfer pump inlet hose. The transfer pump sends fuel to the filter and then onto the high-pressure pump via a pump supply line. A high-pressure line from the pump supplies the common rail with fuel, and high-pressure lines from the common rail supply the injector connector tubes with fuel. Note that to avoid damaging components, you should always use a backup wrench when removing and installing the high-pressure line at the injection pump outlet, and where the high-pressure lines attach to the connector tubes. In addition to the fuel supply and fuel injection lines we've just described, there are a number of lines that connect to a common return to route excess fuel back to the fuel tank. One of these lines routes excess fuel from the high-pressure pump to a junction at the fuel filter housing. Also connected to the fuel return is a line from the cylinder head that routes excess fuel from the injectors. In addition, there is a line from the pressure limiting valve, which is a device aimed at preventing excessive pressure. A line from the fuel filter housing routes the excess fuel from these sources back to the tank. One thing to note in servicing return lines is that only one of the banjo bolts used in the lines has a check valve. The check valve is located at the cylinder head outlet. Be sure not to substitute another banjo bolt for the one in this location. In order to see the rest of the fuel system components, we first need to remove a few components from the top of the engine, beginning with the breather cover. An oil separator is located in the breather assembly. As the name implies, its job is to separate oil from the crankcase vapors and return it to the oil pan. A road draft tube still routes vapors from the crankcase, but with the addition of the oil separator, there is no oil collection bottle to be checked and emptied. Under the breather cover is the cylinder head cover, also referred to as the valve cover. Note the gasket located in the groove at the bottom of the cover. This gasket can be reused as long as it remains in place and is not damaged. You'll need to remove the cylinder head cover to service the fuel injectors and the fuel injector connector tubes. There are several items worth noting when it comes to injector service. As mentioned earlier, be sure to use a backup wrench whenever connecting or disconnecting a high-pressure line from a high-pressure connector tube. Also, be aware that there is a new tool used to remove the connector tubes, number 9015. These connector tubes are directional, and on reassembly, the locating balls on the tubes must engage grooves in the cylinder head. The injectors use an electromechanical design. 3 pass-through connectors in the rocker lever housing are used to route wiring to the injector terminals. A couple of items are worth noting here concerning the terminals. First, up to 90 volts can be present at the terminals, so take care not to touch them anytime the ignition is on. Second, the terminal nuts have a torque spec of 11 inch-pounds. Excessive torque could snap the terminal, and if that happens, you'll need to replace the injector. Injector removal and installation is another area where you'll need to pay strict attention to the service information. The exhaust rocker arm must be removed to remove injectors, and that means you'll need to reset valve lash after injector installation. A new essential special tool, number 9010, is now used to remove injectors. You'll need to temporarily remove a rocker lever housing bolt and screw the tool stud into the bolt hole. When removing the number 6 injector with the engine in the vehicle, you'll need to separate the stud from the rest of the tool and install it first, and then the rest of the tool. Once you've removed the injectors using the tool, another new special tool, number 9007, can be installed in place of injectors for compression and leak down testing. Injector installation is not simply the reverse of removal. Establishing the correct torque on the injector fasteners and the connector tube nut is critical, as is the torque on all fuel system components. To ensure a good seal, injector fastener tightening is done in 3 stages, and connector tube nut tightening is done in 2, so be sure to follow the steps in the installation procedure. The sequence is summarized in this month's reference book. If you do need to replace fuel system components, or if you need to disconnect components for some other repair, remember the system is self-bleeding, and you should never loosen high-pressure lines during engine operation. The HPCR fuel system develops extremely high pressure, which can cause injury or death. The valve train components on the HPCR Cummins diesel engine are similar to those you've seen on previous Cummins diesel engines. Replacement valve springs can be used on either the intake or exhaust valves, and there's no need to change exhaust valve springs when installing a Mopar accessory exhaust brake. You can still distinguish intake from exhaust valves by the dimple in the exhaust valve. There is one item related to valve train components that you need to be particularly careful with to prevent leaks: the rocker lever housing. Just as with the cylinder head cover, if the gasket falls out of the housing groove, the gasket must be replaced. And the housing must be lowered straight down onto the cylinder head during installation. The air intake and exhaust system components are for the most part similar to those used on previous engines. Attached to the intake manifold cover is an air intake heater operated by the engine control module. The intake manifold is integral with the cylinder head. The intercooler is similar to the one used on the previous engine. However, a new tool is now available to check the intercooler and related components for leaks. We'll discuss the tool in more detail later in the program. On the exhaust side, the exhaust manifold now uses two lock plates, which are not reusable. The turbocharger is also similar to those used on previous engines. The turbocharger wastegate is not adjustable. Just as with previous engines, customers can help keep turbochargers operating properly by following the recommendations for allowing turbo RPM and temperature to decrease before turning off the engine. These recommendations are located in the owner's manual and involve running the engine at idle for a period of time before shutting it down. Downstream of the turbocharger, engines that meet California emission specifications have something you're probably not used to seeing on a truck with a diesel engine: a catalytic converter. The converter is used to reduce the emission of oxides of nitrogen. Cylinder head sealing also has some new features worth noting. Cylinder head gaskets are available in 4 different thicknesses to accommodate piston protrusion. 2 are used with new engines, and 2 more are used with remanufactured engines. The gasket thickness is indicated by the number of holes on the tab on the front of the gasket. Be sure to refer to the service information when selecting replacement head gaskets. Well, that does it for the front end, fuel system, and top end components. Next, we're going to look at the lower end components along with the lubrication and cooling systems. The lower end of the Cummins engine has also undergone some changes which affect service. The oil pan can still be removed with the engine in the truck. However, you will need to raise the engine and support it with the driveline support fixture number 8534 and 2 new essential special tools, number 8534-13 and number 8534-14. You can also use these tools when removing the camshaft with the engine still in the truck. After removing the oil pan, you'll notice the bolts that attach the stiffener plate to the bottom of the block. When installing this plate, note that one of the fasteners has a lower profile to clear the oil pump suction tube. Using one of the other fasteners in this location could damage the tube. The pistons used on the new Cummins engine have several features you need to be aware of. For one thing, the engine uses only one grade of piston. As mentioned earlier, head gaskets are available in different thicknesses to accommodate piston protrusion. Early build engines have machined rods, but these will change to a cracked cap design later on. And of course, it is extremely important not to mix the 2 types of rods. The last piston feature we need to discuss involves the lubrication system. Standard output engines continue to use saddle jets located in the upper main bearing saddles to spray the connecting rods in the pistons. In high output engines, these saddle jets are plugged because HO engines use a new system, which includes a component called a J-jet for each piston. The J-jet nozzle is bolted to the block and directs a stream of oil to the underside of the piston. HO pistons have a passageway to direct the flow of oil through the piston head to cool it. To prevent damage to the nozzle and loss of lubrication, the J-jet must be removed from the block before removing the piston. In fact, you need to take care anytime you're servicing the lower end to avoid damaging the jet. There's one more item that you should be aware of in the area of engine lubrication, and that is that the oil pressure regulator now dumps to the pump instead of to the pan. The cooling system for the Cummins HPCR diesel engine uses HOT coolant. The interval for changing the factory fill coolant is 5 years or 100,000 miles, whichever comes first. Automatic transmission applications continue to use an oil-to-coolant transmission oil cooler. It has a new location near the starter motor. There's also an oil-to-air cooler in front of the radiator. The radiator cooling fan used with the Cummins HPCR engine is quite a bit different than the fan used with the previous engines. The fan still uses a viscous drive. Now, however, the drive is actuated electronically by the engine control module. The controller looks at inputs from coolant, air intake, and transmission temperature sensors and the AC status, and then sends a pulse width modulated signal to the solenoid in the fan drive. The solenoid controls the viscous fluid to match fan speed to vehicle operating conditions. There are a couple of items to be aware of when servicing the new fan or adjacent components. First, the fan blade and drive assembly is now right-hand instead of left-hand thread. Second, it is critical to route the fan wiring harness correctly. Failure to do so can cause the wiring to contact the fan and cause damage to a number of components. We'll talk more about the fan as one of the inputs to the new engine control module when we discuss the engine controls coming up next. Along with the changes to the engine and engine systems we've seen so far, there have also been a number of changes to the engine control system. Let's start with changes to the control modules. The Cummins HPCR engine continues to use an engine control module supplied by Cummins. However, this is a new module with the designation CM845. The new ECM handles almost all engine control functions, and all AC functions are now in the engine control module. On trucks with automatic transmissions, a JTEC controller handles transmission and cruise control functions. To accommodate additional inputs and outputs, the ECM now uses 50 and 60 pin connectors. To prevent damaging terminals, avoid back probing these connectors when performing diagnosis. We don't have the time in this program to discuss all of the inputs and outputs to the new controller. However, we can briefly describe some that have been added as a result of the engine's redesign. On the input side, the crank sensor, in combination with the cam sensor, now supplies the ECM with the engine speed signal. The fuel pressure sensor on the common rail is another new input, as is a fan speed sensor. The AC request has also been added, and on manual transmission applications, the cruise control switches. These new inputs are used by the ECM to make decisions regarding the new outputs. These include the injector solenoids. Besides actuating the solenoids, the ECM also controls injector timing and duration. The ECM uses the fuel pressure sensor to control the electronic fuel control actuator in the high-pressure pump. And the ECM uses feedback from the fan speed sensor to control the viscous fan drive. The engine control module uses several inputs in deciding when to engage the AC clutch. In addition to these outputs, the ECM now controls the generator field, and on manual transmission models, the cruise control. As you might have guessed by now, all of the changes we've looked at so far have also brought along with them changes to diagnosis. And that's the subject of the next part of this program. It's always important to use up-to-date information for diagnosis and service, and this is particularly critical when you're working on new components or systems, such as the Cummins HPCR. Service information for the new Cummins engine can be located in a number of places, depending on the system or components you're working on. Group 7 contains cooling system and accessory drive components. Group 8 covers the engine control module and JTEC controller. Group 9 has information about the engine assembly itself. The exhaust system and turbocharger are in Group 11, while Group 14 covers the fuel system. Some diagnostic information is available in these groups. However, the bulk of this information is located in the separate section for diagnostic procedures on the MDS-2, or in the printed Powertrain Diagnostic Procedures Manual. Additional resources are available in the form of training classes. Be sure to see the Training Tips section of this month's Tech News for further information. The tools used to diagnose the Cummins HPCR have also changed to accommodate the many new features of the engine. The DRB3 is now the only electronic tool used to diagnose the Cummins diesel engine. In the engine menu section under System Tests, the injector kill test has been modified, and the generator full field test has been moved from JTEC to ECM controlled items. There's also now a transfer pump test which actuates the pump. You no longer use actuators to do this. The trouble code selection remains much the same. However, you need to be aware that there are many new DTCs and that some P-code designations have changed. Several new readouts have been added to the sensors and inputs/outputs. Among them, several new fuel pressure readouts, and the fan speed in RPM, and the fan duty cycle in %. Under Monitors on the DRB3, you'll find a new selection, Trip Information, which is not related to the type of trip used with OBD2. Instead, you'll find a variety of items related to engine operating conditions. The trip information can be reset using an item under the Miscellaneous selection on the DRB3. Also located under Miscellaneous is a VIN rewrite function used when reprogramming or replacing engine control modules. The actuators on the DRB3 have undergone some changes which correspond to changes in engine components. For example, you can now actuate the fuel control solenoid in the high-pressure pump. Earlier in the program, we looked at some of the new special tools used in servicing fuel system components, such as the injector connector tube remover tool, number 9015, and the injector remover, number 9010. There are a number of other new special tools associated with new diagnostic procedures for the Cummins HPCR engine. These include special tool number 9008, an injector wiring jumper harness, number 9011, a fuel line blocking tool, number 9012, a 12mm test fitting, number 9013, a 14mm test fitting, and number 9014, a different 12mm test fitting. The use of the jumper harness is straightforward. It's installed on the wiring harness side of a pass-through connector. The tool allows you to check for signals to the two injectors each connector serves without having to back probe. It's important to pay close attention to how and where the rest of the fuel system tools are installed. It is possible to install the tools improperly and even to cause damage to components. To help you become familiar with these tools, let's look at how they're used as part of several fuel system tests. In the lift pump flow and inlet restriction test, the check for restrictions is made with the fuel pressure adapter 6631 and a vacuum gauge, while the flow check is made with a new special tool, number 9014. More specifically, the fuel pressure adapter is installed between the line from the fuel tank and the transfer pump inlet hose, and a vacuum gauge is attached to the fitting. For the flow part of the test, you need to remove the banjo connector bolt at the high-pressure fuel pump inlet and install special tool number 9014. This tool blocks off the inlet while allowing access to the fuel supply by the transfer pump. Connect one end of a hose to the test fitting and place the other end in a 1,000 milliliter graduated cylinder. At this point, you need to use the DRB3 to actuate the transfer pump for 10 seconds. If the vacuum gauge reading is greater than 6 inches, then you'll need to investigate the transfer pump fuel supply for a restriction, as detailed in the diagnostic procedure. If the vacuum gauge reading is less than 6 inches, there is no significant restriction in the fuel supply to the transfer pump, and you can remove the adapter and proceed to the flow part of the test. To do this, you first need to empty the fuel that flowed into the graduated cylinder during the restriction part of the test, and place the hose from special tool number 9014 back into the cylinder. Then, once again, actuate the transfer pump with the DRB3. If you have more than 380 milliliters of fuel in the graduated cylinder at the end of the 10 seconds, the fuel supply side of the system is working properly. If you have less than 380 milliliters, you'll need to install a new fuel filter and repeat the test. Insufficient flow with the new fuel filter points toward the transfer pump itself as the most likely cause. Poor performance on the fuel supply side of the system can also be caused by a leak. you can use the steps in the fuel system vacuum test to see if this is the case. You'll need to use tool number 9014 for the part of the test that checks for leaks from the transfer pump to the high pressure pump. To do this, install tool number 9014 at the inlet on the high pressure fuel pump. Once again, this blocks the pump inlet while providing access to the fuel supply line, filter, and transfer pump. To seal the other end of this part of the fuel supply, block off the inlet hose at the fuel transfer pump. You can do this using special tool 6631 and clamping off the hose. Next, attach a hand vacuum pump to the test fitting and apply vacuum to the components. Do not exceed 15 to 20 inches of vacuum. If the system drops more than 1/10 of an inch of vacuum per minute over a 5-minute period, you'll need to isolate and repair the leak. Even if the gauge reading holds, you still need to visually inspect the components for leaks after reconnecting them and starting the engine. The next test, the fuel pump return flow test, makes use of tools number 9012 and 9013. The first part of the test checks the operation of the pressure limiting valve. For this check, remove the banjo connector bolt from the pressure limiting valve on the fuel rail and install fitting number 9013 in its place. Then attach a hose to the test fitting and route it to a container. With the test equipment in place and the engine at idle, observe the end of the hose for fuel flow. If fuel flows into the container, the pressure limiting valve is not doing its job and should be replaced. If there is no fuel flow, you can remove the test equipment, reconnect the limiting valve line, and proceed to the second part of the test. The second part checks for excessive fuel return flow from the high pressure pump itself. Note that for this procedure, the engine must be at operating temperature. To set up the test, first remove the banjo connector bolt from the fuel drain tube at the rear of the fuel filter housing and install number 9012 in its place. The installation of the tool here isolates the return flow from the high pressure pump. Attach a fuel hose to the test fitting and route it to a graduated cylinder. Then start the engine and let it idle for 1 minute. Flow should be less than 1,000 milliliters per minute from the fitting. If it exceeds this, the high pressure pump is defective and will have to be replaced. This isn't the only test in which excessive return flow can indicate a problem. Excessive flow is also used to troubleshoot the injectors and related components for leakage. For this test, once the engine has been warmed up, remove the banjo connector bolt from the rear of the fuel filter housing and install tool number 9012 in its place. Install a hose on the test fitting and route it to the fuel tank or a fuel container. Once again, this isolates return flow from the high pressure pump so that our next test connection can measure return fuel from the engine. For that, you need to disconnect the vehicle fuel return line from the engine fuel drain tube and install a hose on the end of the tube. This hose should be routed to a graduated cylinder. With the test equipment in place, start the engine and let it idle for 1 minute. At this point, if flow is less than 180 milliliters per minute, this part of the fuel injection system is operating properly. If the amount exceeds this, you may have a leak between the high pressure connector tubes and the injectors. You can eliminate these as a cause by shutting off the engine, removing the high pressure lines, and retorquing the connector nuts. Be sure to use the torque specs in the service information. If this still doesn't bring the flow below 180 milliliters per minute, you need to check for leakage past the injectors and related components by isolating one injector at a time. And this is where tool number 9011 comes into play. It's used to block off fuel between the fuel rail and high pressure connector, one injector at a time. When the fuel amount falls below 180 milliliters, you need to inspect the blocked off fuel injector and related components for damage or wear. Besides new special tools for the fuel system, there is also a new tool for troubleshooting the air induction system. The Charge Air Cooler Pressure Tester, special tool number 9022, is installed at the turbocharger inlet after the removal of the filter housing and inlet tube. Besides tightening the band clamp to specs, you'll also need to secure the safety chain to a solid anchor. After attaching shop air, use the tool regulator to slowly pressurize the system to 20 psi. You can then use a soap and water solution to check for leaks. Be sure to use the regulator to depressurize the system before removing the tool. Once again, remember that the steps we've just looked at are part of larger overall diagnostic procedures and were mainly intended to show the proper use of the new tools in the new tests. When troubleshooting the Cummins HPCR engine for specific trouble codes or symptoms, always refer to published diagnostic procedures. And always use the 6-step troubleshooting procedure as an overall guide to your diagnosis. That's all we have time for this Mastertech session. Be sure to join us next month for an update that includes recently introduced powertrain components.
Wow.
Opportunity of a lifetime.
Oh, I think it's great.
I'm having fun.
So it's literally a once-in-a-lifetime opportunity.
Memories of the Ultimate Race Weekend are fresh in the minds of these 5 lucky people, all gold-certified service technicians. For one day, they were members of a NASCAR Winston Cup pit crew. This was all part of a contest sponsored by Mastertech as it celebrates its 55th anniversary. The technicians had to submit a question to the crew chiefs of the Dodge NASCAR teams. One winner was selected from each business center, so 5 technicians came to Detroit on an all-expense-paid trip to be honorary pit crew members at Michigan International Speedway for the Pepsi 400 and to participate in the Woodward Dream Cruise activities.
It's a great honor and opportunity to be here at Daimler Chrysler in Detroit. I've never been here before in my life, and I'm just really excited to be here and to get an opportunity to be here at the Dream Cruise, be here at the Black Tea Party for the 3rd annual event for it, and wow, I get to be part of a pit crew member for Winston Cup.
Oh, I think it's great. I love racing, and I've been looking forward to this since they announced the contest.
And actually will be assigned a position on the pit crew to work with the teams here.
We work on cars for a living, and they do too. But it's got to be a totally different circumstance when the level of competition is that high.
I love it. It's one of the greatest things I've done in a long time.
Yeah, that's just something you can't buy your way into. So it's literally a once-in-a-lifetime opportunity.
To start off the weekend festivities, the winners attended the 3rd annual Black Tea Charity Party held at the Walter P. Chrysler Museum. This is the corporate kickoff to the Woodward Dream Cruise activities. Then it was on to the Woodward Dream Cruise, where winners enjoyed corporate hospitality. The event attracts 2 million people paying tribute to cars, music, and memories.
Wonderful with all of the things that's going on. The Woodward Dream Cruise, the biggest assembly of hot rods and classic cars that I've ever seen anywhere in the world, you know. I'm having fun looking at some cars.
Then on Sunday, it was the Ultimate Race Weekend as the winners sat in the pits for one of the Dodge teams.
They were really up in the sky. They were so excited about participating in the Dream Cruise and then going to the Speedway, Michigan Speedway, there Sunday, and therefore really having all of it in one weekend. And obviously they were real car nuts and said they never had anything comparable with that, and they're really looking forward to this weekend. So that's another extension of our family.
There's many of us out there, and I'm just one of a few that was selected for this. I'm honored.
In addition to all of the activities, the service technicians also had a chance to tour the Daimler Chrysler Tech Center. Here they had a chance to see firsthand why training is so important.
Seeing the facility actually firsthand and seeing this wind tunnel, you don't even fathom what the size of it is until you're standing there next to it and realizing that this is where technology is going, and we have to have these advances. And Chrysler's been on top of it for some time.
Get your training and your certification and keep up on it on a regular basis so you can do your job properly.
It's critical. With the way the cars are advancing nowadays, for any dealership's team of technicians to stay on top of those changes as they come about is a heck of a task.
What I can say to all my fellow technicians is you keep doing your Mastertech, keep on working at improving your craft.